How much do you understand about the universe edge? What lies beyond our solar system has always remained a puzzle, and we won't be satisfied until we find out. This was the strategy when NASA sent the James Webb Space Telescope to the outer limits of space. Since then, the James Webb Telescope has only been incredible. And the fact that it was found at the edge of the universe is horrifying. What does the James Webb Telescope find at the edge of the universe? And what does it have to do with us? Join us as we talk about the scary structure that James Webb discovered at the edge of space and how it totally alters everything. Is there something else out there? One of the greatest questions you could ask is, what lies beyond the acknowledged boundaries? What extends beyond the boundaries of our maps? People have been asking this question since always. It's hard to know what to say. Before addressing the question about what exists beyond the universe, we must explain what we mean by universe. If you think of the universe as everything that could exist in all of time and space, then there can't be something beyond it. Although, if you can save the universe to a specific size and there is something beyond that volume, that thing must also be a component of the universe. Although the universe had no name, shape, and nothing within it, it'd still be an item and appear on the list of all things. By description, it'd be a part of the universe. If the cosmos is as big as it can be, you have no reason to fret about this paradox. Since the universe is the only thing that exists and has no edges, there is no outside to think about. Yes, the part of the universe we can see has an outside light that moves at a finite speed. And the universe's age is also finite. So we have not seen light from every galaxy in the history of the universe. The known universe is 90 billion light years wide right now. There are likely more random stars and galaxies past that line. Following that, it's hard to say because cosmologists don't know if the universe is infinitely big or just very big. Astrophysicists instead look at the universe's curvature to figure out how big it is. The universe's basic shape can be figured based on its geometric curvature at very large scales. So it is feasible that the cosmos is endless. Arithmetically, it has a limited volume if it is flat. Recent findings and measurements of its curvature show that the universe is almost flat if it is curved like the Earth's surface. This might make you think there are infinite universes, but the universe doesn't have to be that big. Even if it's a flat tire, think about how the surface of a cylinder shows this. It is mathematically flat and has a limited size because lines drawn on the surface stay parallel. This is one way to explain what it means for something to be flat. It's probable that the universe is also flat and closed in on itself. Even though the universe is limited, that doesn't mean it has to have an edge or outside. Our three-dimensional universe could be a part of a larger, multi-dimensional structure that is fine and doesn't appear in some strange physics models. You might think of the cosmos as a big ball full of stars, galaxies, and other exciting things about space. You can imagine what it looks from the outside, like how an astronaut might see Earth from an orbit above. However, seeing the universe from the outside is not essential for it to exist. The universe is the way it is. A three-dimensional universe can be defined in a way that doesn't require outside of that universe. This is true from a mathematical point of view. When you imagine the universe as a ball floating across space, which math doesn't require, you're playing a trick on your mind. Obviously, it doesn't make sense that there may be a limited world with no space beyond it, or perhaps even nothing in the mathematical sense of an item that can't be described. It's feasible that the universe has an outside but doesn't have to have one. Nothing in math says it has to have one to explain the universe. Don't stress if this all seems complicated and hard to understand. The point of making math that is hard to understand is to give us the tools we need to understand things that are hard for us to grasp. One of the great things about modern cosmology is that it lets us look into things that are hard to imagine. The depth of field of big telescopes allows them to see billions of years into the past. The Hubble Space Telescope is being replaced by the James Webb Space Telescope, which can check the time immediately. After the Big Bang, when the initial stars and galaxies were made, we see a calm part of the universe with cool old galaxies. If we look 100 million light years away, the space between is mostly empty. But the early universe appears very different if you use advanced telescopes to look billions of light years away, which is billions of years back in time. A large black hole at the center of many galaxies spills out clusters of particles into space, generating shockwaves there. Or they have crazy shapes and make new stars quickly. And even though computer models show that young galaxies can only grow by slowly eating up smaller ones, they start to look massive soon after the Big Bang. Astrophysicists have seen radiation from an origin so far away that it is almost at the end of what we can see. Yet, there must be many galaxies and quasars far away that we still can't figure out, since it takes time for light waves to move across space from where they start to where they are seen. When we look out into space, we are looking back in time. So we can see distant parts of the universe as they existed in history. The Big Bang Theory says that the universe came into existence with a massive blast and had been growing since then. Before galaxies and stars were established, the universe was saturated with hot, sparkling gas and could not be seen. At some point, during the first million years after the Big Bang, the growing and cooling gas turned clear. So we can only look far away and back in time until we arrive at a point in the far distance we can see as it was when the universe was clear. Beyond that point, space is ambiguous, so light waves can't reach people. We can only see the light left behind the hot gas, which cleared away when it cooled to about 10,000 degrees Celsius. The universe's expansion has caused this glow, which started as ultraviolet light and moved to longer wavelengths to become a background of microwave and infrared radiation. So this microwave background is the radiation that comes to us from the edge of the universe that can be seen. The JWST just broke a new record that could help us learn more about the dark ages of space. Using the first batch of JWST info, a group of scientists from different fields found a galaxy formed about 250 million years after Big Bang and established a new record for redshift with a value of Z equals 16.7. This is a fascinating finding because it shows how well JWST works. The Cosmic Evolution early released science survey was made just for JWST imaging, based on data from near cameras. The JWST's primary camera is the near-infrared camera. The study found that Sears 93316 can't be a low-mass star or an active galactic nucleus that isn't blocked by anything. Cosmologists want to know what happens in galaxies that are so young and close to the Big Bang, like Sears 93316, which is only about 250 million years old. Just after Big Bang, when no stars had been established, the universe went through a time called the Dark Ages. This galaxy's findings have brought us closer to the time when we think the first galaxies ever existed. There are still many questions about how and when the first stars and galaxies formed. It's interesting to think about how much farther back in time this space observatory can see, and whether it can truly see the Big Bang in redshifts higher than 20. JWST could see galaxies less than 200 million years after the Big Bang. Even though it's probable that these galaxies won't be straightforward to find, the revelation of Sears 93316 gives us hope that they could exist. This recent study, which cracked the redshift record, utilized the universe's most distant object ever evaluated. The James Webb Space Telescope will look into the universe's strange beginnings and frameworks. It will also look at planets that are far away and orbit other stars. And that brings us to the end of this video. Feel free to let us know what you think about this video, and if you like this video, then please leave a like and subscribe to our channel for more amazing content. Thanks for watching, and we'll see you in the next one.